Okay. So when I say data types, okay, data types, when I say data type, it's not something that is strange. It's very simple. The whole thing is like this. You see, we created a variable, and the variable, we are going to put stuff into it, okay? But the way it is, just like when you create the name, you create a variable name. The computer understands that you want to create a space in the memory, and then goes into the memory, that's the RAM, and create a space and name it as such, okay? So that anytime we call that name, whatever is stored in that space is what is brought out. Please, I hope you are clear. So in the same way, because the computer creates it when you give it a name, you need to also help the computer to understand the kind of data that is stored there. The computer has to understand the kind of data that is stored inside that particular space, which you have given that particular name to. And that is what we want to look at today, okay? In programming, and in every programming language that you find, you see that there is a convention in terms of the kind of way to specify so that the computer will know there is this kind of data that is being stored there. Okay, there's a convention on that. Okay, so that's what we want to look at. Okay, so just a minute. We want to look at, first of all, okay, so let's go on. We have 3 types of data that is stored in every computer memory. One, it can be a number. Okay, the data can be a number. 2, it can be it can be a number that is used for calculations, okay, for arithmetic operations. Then 2, it can be a number or any other thing, any letter, any special character, Chinese character, anything at all, any character at all, okay, including Roman numerals, the normal numbers we know, anything at all, okay, which you don't want to use for computation, but you want to just use it to say something or to display something on the screen. Please, I hope you are clear. Yeah, so that one too is, we call them characters, strings of characters, okay, or characters. Then the last one is when it is a true and false data. So inside that location, you can store something which is true or false there. So it's only 2 things, true or false. Yeah, that can be stored there. So these are the 3 categories: numbers, characters, then true and false. So the true and false, we call them Boolean. So that's what we want to look at today. Okay, I hope you all got what I said. Okay, so let's go quickly and go on to. Okay, so go on to the next one. So let's look at this one, what is written here, and I'll go to the next slide. So I hope with what you are seeing on the screen, you get whatever I've been saying right now, okay? Okay, so if you don't understand anything in what is written here, you can let me know. Okay, so as I said earlier, the data type will help the computer to know the kind of data that is stored inside that particular storage space. Okay, so let's go on and look at the types. Okay. So let's look at this one. All variables must be declared with a data type before they are used. Yes. Each variable declared does not change over the course of the program. So when you declare a variable to be in a particular, with a particular data type, you can't change it unless you do a typecasting. We call it typecasting. We'll look at that when you're using a natural programming language. Then only certain operations can be allowed when you are using a particular, for example, if you are saying that it's supposed to be a number, it means that you can do plus, minus, multiplication, all the arithmetic operations on it. But if you are saying it's not a number, you can't do that on it. If you do that on it, it will convert it to the ASCII code form and then do it for you. You understand that as we go on. Okay, so let's go on. That's what he's saying in the last point here. That if you try to perform an operation on a certain data type, which is not supposed to be performed on it, it's illegal. Okay. Okay, so let's go on. So an example is like, can you multiply Steve by Steve? No, you can't multiply, but you can multiply 2 by 4. Are you okay? Yeah. Okay, so let's go on. So we are going on to data types. Okay, the kind. So the numbers can be classified into 2 main types. We have, you see the first 2 here, 4 integer types and 2 floating point types. These are the 2 main types of numbers, data types that we use. And these words you see in brackets here, okay, these byte, short, int, long, float, double, boolean, these words, okay, are the words which are used to specify to a computer. So any programming language you are using, if you use these words, the computer understands that this is the kind of data you want to store inside that variable. Please, I hope you are clear with me. So let me take the integer part. So if you want to store an integer, that is something which is not having a decimal place. Something that's not having a decimal place. Then you use these 4 integer types. Emmanuel, please, when you come online, mute yourself. Thank you. Okay, so you have these 4 integer types. Byte, short, which is the short actually means short int, okay, integer. Then int, which means integer. Then long, which means long integer. We even have long there and all that, okay? Then we have, when it is, the number is, so it's a number that is having a decimal place. Then that one we say, we use the word float, which means floating point, or double, which means double floating point. Okay, so these words are what is used to specify that this is storing a number. But if you use the first 4, byte, short, int, and long, they specify that it's only an integer. It's either a negative or positive number, but it's not having a decimal part. And if you specify that it's float or double, you also specify that it's a number, but you're saying this time that it's a number which can be positive and negative at the same time, but at the same time, it's also having a decimal place. I hope this makes sense. Okay. Then if you use bool or boolean, some programming languages allow you to say bool. Others will let you want to spell it in full, boolean. Okay. It's somebody's name. You can check, you can research on him. He was the first person to bring that kind of arithmetic, binary arithmetic, into mathematics. He pioneered the binary arithmetic in mathematics. Okay. So all the discrete math you are doing, the digital electronics you are doing, you can go and beat this man for it. Meanwhile, he's not alive anymore. He made all these things come to pass. Okay. And it has helped for the computer to be very useful. Actually, I didn't know the computer would be like this anyway. So I'm just simply saying that Boolean or bool is what is used when you are storing true or false. Okay, true or false. They used it to honor him because he's the one who spearheaded that binary arithmetic. Okay. So Boolean is what? True or false. Please, I hope you are clear with me. Okay. Then char is standing for character. Okay. And this is when you are storing anything which you not use for any arithmetic operations. In the same way, bool too, you cannot use it for arithmetic operations. Or boolean, you can use it for arithmetic operations. But the first two, the numbers, you can use them for arithmetic. If you specify that a variable is that, whatever you put inside that variable, you can use it for arithmetic operations. But the last two, which is boolean and char, when you specify a variable that it is boolean or char, you cannot use it for arithmetic operations. Okay? So when you say something is char, so you say char msgn, what you're saying is that that variable msgn is supposed to store only characters. When you say characters, it's anything is a character. Okay, anything that can be written is a character. Plus, minus, comma, full stop, 9, 0, 1, 2, 3, 5. Anything at all is a character. Okay, so space, all of them are characters. Okay, so anything at all that is written is a character. Chinese characters, Russian characters, anything at all is a character. So when you say something is char, what you're saying is that it's supposed to store a character. But in this case, you are saying that it's supposed to store just one character, just one. One, not two, one. Okay, just one character. So that is what char does. So when you specify that I have char msgn, what you're saying is that it's supposed to store just one character, just one. One. Okay, so I'll demonstrate it by running C++ tomorrow for you to see what I'm talking about. Maybe it may not be tomorrow. Maybe tomorrow we may meet earlier. I may meet you earlier. I have an engagement, so I may meet you earlier. So I'll let you know of the time. Or when we are done, I'll let us discuss it if it's okay for you. Okay. So let's go on to the next one. So let me explain. When you say something is byte, okay? When you say byte num, what you're saying is that that variable num is going to store a number. But that number will be an integer. Okay? That's not having a decimal place. But that integer will be limited in size. That's the number, the kind of number you can store, the kind of integer you can store in that num will be from -128 to +127. Please, you understand it? That's the range. So anything beyond these ranges, num cannot store it. Because you said it's byte num. You specify that byte num. Please, I want you to follow very closely. Okay. Then if I say short, okay, short num, what I'm saying is that it can store numbers which are integers. Okay. Okay, does not have a decimal place. And it can store numbers which are from 32,000, -32,000, all the way to +32,000. Are we okay? Okay. Then if I say int, you can see there. If I say int num, I'm saying that please create a space called num. It's going to store only numbers which are integers. And those numbers which are integers, it can store from 2 billion, yeah, it's a billion, 2 billion, -2 billion to +2 billion. Are you okay? Okay. But if I say long num, then I'm going way beyond. Then that one I'm going in the zillions. You can see the range there. Okay. And I told you we even have long int. And even long int. Sorry, I said long int. We have long, we have long there. Okay, so that is it. At this point, do you have any question? Okay, so we'll try some, you see it. Then we go on to the next one. Then we have an example. So if I say I'm declaring a variable, and I say int high score. Okay, the variable that the data type is int, the variable name is high score. Are you okay? So the data type is int, variable name is what? High score. Keep that in mind. So that is so that's how you declare a variable. You bring the data type first, then bring the name. Okay. Now, for C++, for Java, and other languages, they normally require you to do this. But some languages are very, I'll say flexible. Okay, like Python, they will not allow you to do this. They don't necessarily specify that you should bring the data type first. Okay, yeah. But anyway, what I'll tell you is that always do this because it's the best. But when you are using a particular programming language and it doesn't allow you, it doesn't necessarily require it, you don't need to do it. You don't need to worry yourself. Okay, so Python, what Python does is that you have to give an initial value to the variable, then it will by itself determine the kind of data type you are trying to store inside there. Okay, okay, so we'll look at that. You see what I'm talking about. So there's an example. If I say byte small value, I can store -55, but I can store even 1,000 in byte. If I say int page count, for example, I can store in thousands, in millions. You understand? Then if I say long big value, I can store much more bigger stuff. Okay. I'll review all these things and before I give it to you. Now we come to the float and double. Float and double too is like this. Look at it. When I say float num, I'm saying that please create a variable called num. It's going to store numbers which are supposed to have a decimal side. Okay. And the decimal side will be from negative 0.1, whatever number. Okay, whatever number. And one thing you should keep in mind is that for float and double, the numbers in terms of the part where it is not a point is big. Like you can store a billion, a zillion for all the place before the decimal point. Please, I hope you are clear with me. Keep that in mind. For float and double, it can store any number in billions, in thousands, in billions, it can store them. Okay. Just that it gives limits. The float and double is there to give limit to the decimal places, how much decimal places that it can store. Are you okay? How much decimal places it can store. So you can see 0.4e exponent 45, meaning that it can store up to 45 decimal places in the negative side. Then on the positive side, 38 decimal places for float. But for double, you can see, so Emmanuel, when I'm done with this, you can ask your question. But for double, you can see that it's what? Minus, that's you can store in the negative side 324 decimal places in terms of after the decimal point. Okay. But for the positive side, you can store 308 decimal places. Please, I hope you are okay. Okay, so that's it for the float and the double. Okay. Okay, let's go on to, who is writing on my screen?
Sir, please.
Yeah, please, you can speak.
Okay, sir, please, we're talking about float and double being able to store in billions. Is it like when the billions are in decimal places or billions that have been an integer?
Please, can you speak into the mic well? I'm not hearing you.
Okay, so you said that float and double can store in billions and like that. So like the billions, are they when it's in decimal places or when it's like an integer?
Wow, I'm not getting what you're saying. You are saying that float and double can store. I didn't get what you said well. Hello? Wow. Is Emanuela online? I didn't get what she said well. So if she can come back. Okay.
Okay, so I was saying you said before that float and double can store in billions. So I'm asking, is it like in billions, like is it in decimal places or when it's like an integer?
Okay, I get what you're saying. I'm saying that float and double, okay, they are not, you can use it to store numbers which are not integers. Are you okay? You see, an integer does not have a decimal place. Any integer will never have a decimal place. But when something is floating point or it's a float, okay, that's floating point, it means that it has a decimal place. So what you should understand, when you say float num, then you're saying that that variable, you are telling the computer that that variable called num that you are creating in the RAM will be storing decimal places. It will be storing numbers that have decimal places. So you see that even if you store a number which does not have a decimal place, it will automatically add a decimal place to it. So if I create float num and somebody enters 2 into it, you see that if I want it to display, it will display 2.0 for me. Do you understand? If I want to display that value the person entered on the screen, so that it will display 2.0 for me instead of 2. So it will add a decimal place to it automatically. And I'm saying that for the float, the number of decimal places it can store is in the negative side. That's if you're storing a negative number, it can store up to 45 decimal places. Then on the positive side, 38 decimal places. Are you okay? Then for the double, on the negative side is 324 decimal places. On the positive side is 308 decimal places. Does that make sense? Have I answered your question?
Yes. Thank you, sir.
Okay. Okay, so I'm coming to car and string. Okay, car and string. So when I say car, okay, let me come to the example I put here. So if you look at this, when I say car, first letter of name, it can store only one thing, only one. So you see that I'm putting only one value inside. Okay, car, my question, it can store only one thing. But if I say string, string means, full meaning of string is actually string of characters. Okay, so car, so somebody will be like, why did they even create car if you can do string? They created car because at first when computers started, the way we were typing and having information, it was not like that. It's like, it was not necessary to bring a whole lot of characters like the way we are doing now. Okay, so single characters to explain stuff was okay. Okay, you'll be shocked that one of the operating systems that we're using about maybe 30 years ago, no, not 30, maybe 20 years ago, or 30 years ago, yes, 20 years ago, you'll be shocked that it was in kilobytes. It was not even in megabytes, it was in kilobytes. The whole operating system is in kilobytes. So they were not really fascinated with having a whole lot of information and those things, you understand? So they created a car, okay, for storing, because they thought they would not go beyond that. Storing single characters is okay. Then they realized information is becoming bigger. Then they created a data type, which will be string of characters. So we call it string. So so when I write string, for example, co-author, you see, I'll be able to store a whole name in it. And for string, you don't have a limit. You can store like a whole, even one page of, what do you call it? A thesis or whatever inside it. Okay. Yeah. A whole page can go, or a whole book can even go into a string. Okay. So string can accept a lot of characters. Okay. A lot of characters. And you can see from the two examples that I'm even storing numbers here. Okay. Together with the characters. Okay. And you can see from the first one too, I'm even having space in between two characters. So that's how it is. So for string, you can store basically every character. But one thing I want you to keep notice is this. Look at the way when you are storing strings and characters, you see there's a quote around it, double quote or single quote around them. Look at it. You can see there are quotes around the values. So that's one thing about strings. In programming, anytime you put a quote around something, you are saying that the thing is a string. That particular variable, okay, is a string. It's supposed to store strings. That's what you're saying. Okay. So anytime you are putting something into a variable and you put that thing you are entering in quotes, whether single or double, okay, you are saying that it's supposed to be a string. Okay, so keep that in mind. But for other than that, for all the others, for example, for bool, you see, for bool or boolean, this is what can be stored: true or false. Only two things can be stored in them: true or false. Nothing else. You can't store any other thing like A, B, C, 1, 2, 3. You can't store any other thing except the word true and the word false. Okay, that's the only two things that can be stored. And you see that I don't put any quotes around them. Do you see it? There are no quotes around them. Okay, because they are not strings. Okay, so keep that in mind. And then for the numbers, look at the double and the float. You see that there are no quotes around the values that is being put inside. Okay, there are no quotes around the values that are being put inside, meaning that they are numbers. Okay, the same applies to the integers, the byte, int, and long. You see that there are no quotes around them. So please keep that in mind. It's very, very critical. I've seen that a lot of people do that mistake a lot, where they'll be putting quotes around strings and all that. Is wrong. Okay. So that is it for data types today. I hope we are all okay. So we have an assignment in it where I want you to give me the data type. So let's start with this one and see. So if you have, let's say we want to write a program where one of the input data is supposed to be population of Ethiopia. Okay. One of the input data is supposed to, so for example, a program to store, to take the population of Ethiopia and compute it and use it for computation to find the percentage of males and females and blah, blah, blah. I've given you a program. So the population of Ethiopia that is in will be the input data variable. Okay, so you have to find a name for that. But most before you do that, after doing finding the name for it, I want you to give a data type for it. So based on what you just learned right now, okay, what kind of data type do you think we have to use for population of Ethiopia? Anybody? Anyone, please? Okay, so Emanuela and then David, you are on the floor, so you can speak. And then Michael. Okay, so one at a time. So Emanuela first. Emanuela first. Okay. Population of Ethiopia.
Population of Ethiopia will have to be a string.
Are you sure? Okay, so David, population of Ethiopia.
Wait, population of Ethiopia. Population is a number. So it's not number, it's integer.
It's not string.
No, it's integer.
Yeah.
Oh, I'm waiting. David raised the hand, so I'm waiting for your answer. Okay, so if David is not speaking, let's go to Michael, Precious, and then okay. So Michael, speak before the others will speak. Raise your hand.
Hello.
Yeah, Michael, you can speak.
Hello.
Integer.
Please, can you?
Yeah.
The data type will be int.
Data type is integer.
Okay, who is speaking? Okay, Michael Asamoah. Okay. Mr. Michael Asamoah is the one speaking. Okay, you can speak, please. It was Michael Mensah I was talking about, but you can speak anyway. Mr. Michael Asamoah can speak. You said population of Ethiopia should be what? Hello?
Data type is int.
It should be int.
Integer.
Okay, good. Thank you very much.
Integer,
why integer?
please.
Who can you tell me why? Why integer? Why integer, please?
Population of Ethiopia is numbers. We're talking about numbers.
Okay. So because it's a number, if you give me that reason, I'll not mark you correct. Why should it be integer? That's what you said. So why should it be integer? That's the question I'm asking. Why should it be integer? Why shouldn't it be float? Population of Ethiopia, why shouldn't it be float?
You're talking about a number of, hello.
Because it's not a decimal number.
Is that what?
Because it's not a decimal number.
Good, because it's not. Who is speaking?
Precious, sir.
Who?
Precious. Also precious.
Yes, Precious, you raised up your hand. Yeah. Okay, so okay. So because it's not it's not a decimal, you don't have decimal numbers in it. Are you okay? Okay. So that is why. Okay, I'm coming. Since 4 people are raising their hand at the same time, I have to. Okay, so Precious, that's a very good answer. And then Elijah also raised the hand. Elijah raised the hand. So Elijah, do you have any different idea?
I suggest it should be long.
It should be long. Why?
Because long has no limited range, but for int, it has a range.
Okay.
And long can take a million, and population can go beyond integers.
That's very good. Can go beyond the billion, not integers, but can go beyond the billion.
The billion.
Good.
Yes.
Thank you very much. That's very true. So what he's saying, I hope you understand what he's saying. It makes sense. You understand? So he's saying that if you use int, it's good to use int. It's correct. But if you use long, it's better because you are anticipating. You see, as a programmer, you're a designer. So you're anticipating the fact that the population will definitely increase. You understand? And since it will increase, it's better to use long so that when they get to a billion and pass a billion, you will not now come and say, okay, let me change for the program. Let me go back into the code and change it. Okay. So the program can be self-sustaining a bit. Okay. And then let's go to the next one. Michael Mensah, do you have a question or you want to answer the next one?
I wanted to answer the question, but
the first one.
I would answer the next one too.
Okay, so Michael, what I want you to do for me is that the first one, we have realized that you can use int, you can use long, but long is the best. So give me the declaration. You give me the data type and then the name. Let me type it and let's see it. So give me the declaration quickly.
Long pop. Long POP. Long pop. Yes.
Okay. I want to share my screen and then. Okay, so you said long what?
Pop.
Long pop. Like this. Is that what you're saying?
Yeah. Yes.
Okay. Thank you very much. Okay, so let's go to the next one, and then you give me what the data type is, and then, okay, so quickly, and because our session will end very soon, we are left with just 1 minute. So we'll just look at the next one. Approximation of pi. Approximation of pi.
Float.
Is that what?
Float.
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 Okay, thank you very much. Float. Okay, Precious, you can also speak. Precious, you can speak.
Sir, I think it's constant.
No, I haven't taught anything called constant here. I'm talking about data type to store a variable. I haven't taught constant yet. So what kind? What kind of data type here?
But then it's
Okay, so I think it's float.
Okay, thank you. Float. Okay, Emanuela, I can also speak. Let's go to the next one. Open or close status of a file. Open or close status of a file. Open or close status of a file.
It's Boolean.
Okay. I'm seeing all your chats that you put here, Mr. Boatin.
It's
Okay.
Boolean.
It's Boolean. Okay, it's Boolean. Thank you. Who spoke? Is it Emanuela or somebody else?
Yes, Manuela. And I also have a question, please.
Okay, so yes, it's Boolean. Good, thank you. Then the next one, your name. Your name will be what? Your name, what kind of data type should we use to store it?